In conditional probability, we calculate the probability that an event happens with the condition that another event has occurred. Example, what is the probability that a randomly selected student excels in math given that she or he excels in science? We use the notation PAB. We read this as the probability of event A happens given B has occurred, or the probability of A given B. In a class of 25 students, 19 have fair hair, 15 have blue eyes, 22 students have fair hair, blue eyes, or both. A student is selected at random. Find the probability that the student has A. Fair hair and blue eyes, and B. Blue eyes given that the student has fair hair. I prepared here a two-way table to present the numbers in a summarized form, and it could be easier to understand that way. Okay, so what we do is we label those columns and rows. We have two conditions here. Those with blue eyes, let's say that let's call B for those students with blue eyes. And let's call those students with fair hair F. Students with fair hair. Okay? The columns are for those with blue eyes and not blue eyes. So let's call this B for blue eyes, those with blue eyes, and those with not blue eyes. Okay, and of course the total. And now for the rows, we assign F for those with fair hair. And if you do not have fair hair, let's call it not F. And of course, total. Now, let's use these numbers. In a class of 25 students, meaning the grand total is normally seen here. Okay? And 19 have fair hair and 15 have blue eyes. In this class, 19 have fair hair. So we use this. Out of 25, we have 19 students with fair hair, okay? And 15 have blue eyes. So look for the total of those students with blue eyes. So let's use this space here for that number. 15 have blue eyes, okay? So check. We use this number, we use this number, and we use this number. Okay, so in this case, you can easily say that if out of 25, 19 have fair hair, that means those students without fair hair is 6. Okay, if this is 15 out of 25, then this must be 10. Those students without blue eyes, okay, different eye color. Now, how do we get the numbers here? Let's use this. 22 students have fair hair, blue eyes, or both. 22 students have fair hair, blue eyes, or both. Wait, 22 students. Okay, in this case, I want to use a Venn diagram. Okay, using that number, the count is 22 students, and some of them have fair hair, and some of them have blue eyes, and some of them both. But it was not mentioned the number of students with both qualities. Okay, so let's call this X. So if there are 19 students with fair hair, this must be 19 minus X. And if there are 15 students with blue eyes, this means this is 15 minus X. Okay? All right, so in total we have 22 students. So if we add those expressions together, we have 19 minus X plus X plus 15 minus x equals 22. Because it says so. 22 students have fair hair, blue eyes, and both. Okay, so we can solve for x here. 19 minus x plus x, 19 plus 5 is 20. 34 minus x equals 22. So x is 34 minus 22. So our x here is 12. Okay? So if this is 12, let's use another color. That x here is 12. 15 minus 12 is 3. 19 minus 12 is 7. Okay, so you can use this number to fill in those blanks. Going back to the two-way table, X here means both blue eyes and fair hair. So let's write 12 here. Okay, 19 minus 12 is 3. This is 15 minus 12 is 3. This is 3 plus 7 to get 10. Oh, there's something wrong with my numbers. This is not 3. This is 7. Okay, sorry. Let's do that again. So 19 minus 12 is 7. And 7 plus 3 is 10. 3 plus 3 is 6. Okay. Now we can now solve the probability that a student has, this is probability that a student has fair hair and blue eyes. Fair hair and blue eyes, 12 out of 25. 12 out of 25. So that's our answer. Okay. Now, what's the probability that a randomly selected student has blue eyes given that the student has fair hair? Probability that the student has blue eyes given fair hair. Look for the total number of students with fair hair. So that's 19. Okay, so that's our denominator. What's the probability that out of those people with fair hair, they have blue eyes? So we have 12. So our answer, 12 over 19. Okay? Here's another one. Pause this video, try it on your own. 28 members of a youth group went hiking. 23 got sunburn, 8 got blisters, and 5 got both sunburn and blisters. Find the probability that a randomly selected person got blisters or sunburn, got blisters given that the person was sunburnt, and C, was sunburnt given that the person did not get blisters. Let's assign variables, okay? So those who got sunburn, let's call them S, got sunburn. And the number of people who got blisters, let's call it B, got blisters, okay? And let's use them to label this two-way table. So S, not S, and total. And for the rows, we use B for the number of people who got blisters, no blisters, and total. And let's use those clues, those numbers to fill in this table here. So the 28 members of youth group, meaning we have a total of 28 here. 23 got sunburn, 8 got blisters, and 5 got, okay, 23 got sunburn. So total of, look at this, total of those who got sunburn, let's write it here. So that's 23. And 8 got blisters. So look at this, total number of people who got blisters, let's write it here. So that's going to be 8. And 5 got both sunburn and blisters. Both sunburn and blisters. So let's write 5 here. 5. And let's do the mathematics. 5 plus 3 is 8. 8 plus something, that's 20, equals 28. 23 plus 5 is 28. This means this is 2 and this is 18. Okay? Let's check again. 5 plus 18 is 23. 3 plus 2 is 5. 8 plus 20 is 28. Horizontally, we have 5 plus 3, 8, 18 plus 2, 20, 23 plus 5, 28. So check, our numbers are okay. Now, the question is, find the probability that a randomly selected member got blisters or sunburn. So intersection, okay, sunburn. Okay, we have to use a Venn diagram here. Okay. Okay, so these are people who got sunburn and these are people who got blisters. Or this is end, right? Those people who got both blisters and sunburn is 5. Okay, where did we get that? From here, blisters and sunburn. Okay, and we have a total of 23 got sunburn, right? So 23. Okay, so this means we have here 18. Okay, coming from this sunburn and not blisters. And in this case, we have what are this? Those with blisters but no sunburn. Blisters but no sunburn, meaning that's 3. Okay, so how many people got blisters or sunburn? These are blisters or sunburn. Okay, so 18 plus 5 plus 3 got blisters and sunburn or sunburn. So 18 plus 5 is 23 plus 3 is 26. So the probability of randomly selecting a person with blisters or sunburn is 26 out of 28. 26 out of 28, or 13 over 14. So that's our answer. For letter B, what's the probability that a randomly selected person got blisters given that, okay, probability blisters given was sunburnt, that the person was sunburnt. Okay, so for this S, look at the total of S here. That's 23, so that's your denominator. And from that column, of course, we see that there are 5 who got blisters. So let's write 5 here. So that's our answer. Okay. And for letter C, was sunburnt given that the person did not get blisters. The notation is that the probability S given that did not get blisters. So look at no blisters. Okay. For this no blisters, look at the total of this. We got 20. So that's your denominator. And from this out of 20, look at S. That's 18. So 18 over 20, or 9 over 10. That's our answer. I hope you like this video. Please subscribe and give a like.